less than 4.6 negative and 0 exponents. For any non-zero number, a to the 0 power equals 1. So for example, 4 to the 0 power equals 1. 100 to the 0 power equals 1. Negative 25 to the 0 power equals 1. For any non-zero number a and any integer n, a to the negative nth power would mean that you put 1 over a to the positive nth power. So for example, 4 to the negative second power will turn to 1 on the numerator and 4 to the positive 2 in the denominator. So that's how you change a negative exponent into a positive exponent. Example 1. Write the expression using only positive exponents. That's the directions you will see when we're doing this. So 4 to the negative third power, we put it 1 over 4 to the positive third power. Technically, if you look, this is in the numerator, because there's an invisible 1 underneath. So you're basically switching it to the denominator and switching the 1 to the numerator, but make the 3 positive. For b, the first thing we need to do is change this n to the 0 power. Well, n to the 0 power is 1. So it gets rid of that right away. So honestly, you don't need this 1 anymore because anything times 1 is itself. Now take m to the negative fifth and make it positive. So put it into the denominator and make it positive and 1 in the numerator. For part C, the negative 8 is only with the y. If it was with the other numbers, there would be parentheses around it and the negative 8 would be outside the parentheses. Here it's only with the y. So that means what we're moving to the denominator is just the y to the negative 8th power. So I have 13x in the numerator and y to the 8th power in the denominator. Only move the power that has a negative exponent. Write the expression using only positive exponents. Pause the video and try 1 through 4. Number 1, 33,333 to the 0 power is 1. 7 to the negative third power, again, think of it as bringing this down to the denominator, bringing the 1 up to the numerator, so you have 1 over 7 to the third power. For number 3, the negative 2 is only with the z, so the 2 stays in the numerator. This is what brings down to the denominator. 2 over z squared. For number 4, the x to the negative fourth is the only negative. So you keep 3y, and think of it as starting as a fraction. You keep 3y in the numerator, and you bring down the x to the negative fourth and make it positive exponent. So 3y over x to the fourth power. Rewriting fractions for example 2. Write the expression without using a fraction bar. What that means is now I want my answer to have a negative exponent. So 1 over 15, what I need to do is bring up this 15 to the numerator. When I do, I'm going to have a negative exponent. Well, what's the exponent right now with 15? It's an invisible 1. So what you have is 15 to the negative first power. Okay, again, look at the directions because the directions really tell you what you're trying to get as an answer. And when it says without using a fraction bar, you want a negative exponent in your answer. For part B, I want to get rid of the fraction bar, which means I want to get rid of the denominator. So I want to bring it up to the numerator. To do that, I'm going to make this 5, this exponent 5, into negative 5. The a cubed stays where it is because it's already in the numerator. For this checkpoint, write the expression without using a fraction bar, so your answer should probably have negative exponents. Pause the video, try 5 through 8. Number 5, we have 18 in the denominator. Remember there's this invisible exponent of 1. I'm bringing it up to the numerator, which means I have 18 to the negative first power. Same thing with number 6, 1 over 100 as an exponent of 1. When you bring it up to the numerator, well, you would have 100 to the negative first power. Because it's 100, which is a place value of 10 or a power of 10, you can actually make it so that it's 10 to the negative second power, because 10 to the negative second power is 100 to the negative first. I would accept either answer though. Again, if you're not sure why this is 100, think about the fact that the exponent's telling you how many zeros to add on to it, or that it's going to have. So there's 2 zeros. Number 7, we just need to bring up the denominator. So you have 3 times c to the negative second. Number 8, bring up y to the 7th and make the 7 a negative, so x to the 5th, y to the negative 7th power. This time we're going to use the powers property with negative exponents. So we're going to find the product or the quotient. And we want the answer using only positive exponents. So get rid of those negative exponents then. Before we get rid of negative exponents, we want to solve the product. So we're multiplying powers, which means we add exponents. 12 plus negative 4 is 8. So you have 6 to the 8th power. This is already positive, so you're good. For b, here are the ends that have the same base. There's this 1 here. So you have 7, because 7 doesn't change from the numerator, n to the negative 4th minus 1. You should add the opposite. Negative 4 plus negative 1 is negative 5. This is a negative exponent, so we need to change that by bringing it down to the denominator. Keep the 7 in the numerator. 7 over n to the 5th power. Try 9 and 10, write the answer only using positive exponents. Pause the video. You have a base of 3, you're multiplying powers, so you add exponents. You're going to get 3 to the 3rd power, and that's it. You're done because it's already positive. For number 10, we need to look at simplifying the d's. It's division. Keep 7 in the denominator. So we have negative 4 minus 2. Add the opposite. We have 7d to the negative 6th power. Take the d to the negative 6, and we want to put it into the denominator. 7 is in the numerator, d to the 6th power in the denominator.